All right, welcome to this explainer. Today, we're taking what is literally the most incredibly personal chronological journey imaginable. We are going to trace the steps from a microscopic single cell all the way to the complex, thinking human being you are right now. Let's unpack the biological milestones and those critical environments that shaped all of us. So here's our roadmap for today. We're going to cover 1, the prenatal journey, 2, risks before birth, 3, the infant's world, 4, crucial windows of learning, 5, the science of attachment, and finally, influences on gender. Let's dive right in. Section 1, the prenatal journey. Think about this for a second. Your entire existence started right here. A sperm unites with an ovum to form just one microscopic, single-celled egg. It's wild to think about, right? From this single point of origin springs the entire shebang of human complexity and cognition. And the physical transformation in these early stages is just staggering. We transition from a tiny cluster of cells in the germinal stage to a highly structured embryonic stage, where the midbrain and forebrain actually start forming, straight through to a recognizable human shape in the fetal stage. It's basically biological construction on hyperdrive. Let's map out exactly when this goes down. From weeks 0 to 2, we're in the germinal stage. Then, weeks 3 to 8 mark the embryonic stage. Now, here is a truly fascinating biological fact about this specific window. Between the 4th and 8th weeks, testosterone is secreted in embryos that are genetically male. And without that hormone present right then, the embryo will actually develop to be anatomically female. Crazy, right? Then, after 8 weeks, the organism officially enters the fetal stage, continuing to grow and refine until birth. Moving on to Section 2, risks before birth. Now, all this rapid growth comes with some really severe vulnerabilities. We tend to think of the womb as this perfectly safe haven, but the placental barrier isn't exactly an impenetrable shield. There's actually a massive volume of environmental risks that can disrupt fetal development. We're talking maternal illnesses like rubella and STDs, environmental hazards like X-rays and radiation, pollutants and toxins, and of course substances, alcohol, which can lead to fetal alcohol syndrome, illicit or legal drugs, cigarette smoking, and even high levels of maternal stress. So protecting this incredibly sensitive environment means actively avoiding everyday hazards. Grounding these risks into daily choices like steering clear of high mercury foods, unpasteurized dairy, raw sprouts, certain pain meds, or even environmental heat stressors like hot yoga. It really just highlights how remarkably delicate fetal development truly is. But here's a curveball that often surprises people. Prenatal risks aren't exclusively maternal. Fathers affect prenatal development too. Turns out, the sperm of teenage boys and men over the age of 50 may contain mutations, and these mutations can actually increase their offspring's risk of miscarriage, birth defects, and certain diseases down the line. So yeah, it literally takes a healthy contribution from both sides of the genetic equation to minimize the risk. All right, Section 3, the infant's world. Assuming we navigate that prenatal journey safely, we arrive in a brand new, wildly sensory-rich environment. But infants don't just arrive as helpless blank slates. No way. They are born equipped with reflexes, deeply hardwired, automatic behaviors that are absolutely 100% critical for survival outside of the womb. These early reflexes represent our very first physical interactions with the world. You've got the stepping reflex, which mimics walking when their feet touch a flat surface. There's the sucking reflex for feeding, the surprisingly powerful palmar grasp, and the Babinski reflex, where the toes fan out when the sole of the foot is stroked. These aren't learned behaviors. They're innate survival tools, right out of the box. But this raises a really fascinating question for developmental psychologists. Since infants obviously can't talk to us, how do we actually know what a baby can perceive? How do we figure out the inner workings of a newborn's mind? Well, researchers have to get incredibly creative, and Gibson's visual cliff experiment is a perfect example of this. They set up a glass table with a checkerboard pattern underneath, dropping the pattern on one side to create the illusion of a cliff, while the solid glass keeps the baby perfectly safe. This brilliant setup tests age, mobility, and visual acuity to see when babies actually develop depth perception. Through creative tests exactly like this one, we've learned so much more about what infants experience. Newborns aren't just seeing a blur. They can distinguish contrasts, shadows, and edges. They have a massive preference for looking at face-like stimuli. And amazingly, they can recognize their primary caregiver almost immediately by sight, smell, or sound. How cool is that? Section 4.
crucial windows of learning.
As the infant takes in all this sensory data, the brain goes through explosive growth. This is driven by plasticity, which is basically how easily the brain wires itself based on experience. And if you look here, you can see this plasticity peaks in distinct, staggered phases. First, right at birth and early infancy, we see a massive spike for sensory wiring: vision, hearing, and touch. Once that foundational wiring is locked in, the window for language and speech swings open. Finally, building on both of those, higher cognition, things like reading and math, peaks a bit later in childhood. Which brings us to a massively important concept: the critical period. This is a crucial window of time for cognitive development, and the stakes here are frankly incredibly high. We've seen that when children are removed from deprived circumstances and placed in an enriched environment, particularly before they reach the age of 2, their brains often respond with massive accelerated neuronal growth. But if you miss these windows entirely, development becomes much, much harder. Moving to Section 5, the science of attachment. You know, development isn't just about cognitive wiring. It's about emotional wiring, too. Long before we can even articulate our feelings, we learn how to connect with our caregivers. Psychologists have actually pinpointed 4 primary attachment styles stemming from these early interactions: secure, anxious, disorganized, and avoidant. So, what determines which style a child ends up with? Well, the really heartening news is the resilience of secure attachment. Most children actually form secure attachments despite a really wide variation in normal parenting styles. However, insecure attachment, which wraps up the anxious, disorganized, or avoidant styles, is heavily predicted by severe environmental factors. We're talking about abandonment or deprivation in those critical first years, or parenting that is abusive or erratic, often because a parent is clinically depressed or chronically irresponsible. It can also be influenced by the child's own genetic temperament and highly stressful family situations. And finally, Section 6, influences on gender. As toddlers grow, they naturally start categorizing the physical world, and themselves right along with it. Cognitive psychologists study how children consolidate this early knowledge into what's called a gender schema. Think of it like a mental network, a framework of beliefs and expectations about what it fundamentally means to be a girl or a boy in their specific culture. Children use these schemas to internalize some pretty strict rules about gender. It literally dictates their beliefs about what boys and girls are supposed to wear, what they're supposed to do, how they're supposed to feel, and even what they are supposed to think. And here's the kicker. Once these frameworks are established in childhood, many people retain these inflexible schemas throughout their entire lives, filtering all of their future experiences through this very early cognitive lens. Wow, okay, we've covered an immense amount of ground today in this explainer. We've traced life from a single cell, navigated the hazards of the womb, explored the sensory explosion of infancy, brain wiring, the bonds of attachment, and the construction of identity. It's a lot, so I want to leave you with a provocative thought. Looking back at this timeline, how do you think your unique early environment, those very first attachments and those critical windows, how did they shape the exact person you are today? Really think about it. Thanks so much for exploring this amazing journey with us.